Hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 19 of daily Leetcode challenge for January month, and we have a very good question in front of us. This question revolves around the topic of metrics. And by the way, I felt this was an easy question. If you have already solved it, let me know your thoughts in the comment section. But if you have not solved it, definitely let me see what is your thought after I explain the solution. Okay. So this is question 931, minimum falling path sum. So as you can see, we are given square matrices basically. As you can see, n cross n matrix is given to us. It's a called matrix. Return the minimum sum of all falling paths through matrix. So yeah, there is nothing much to understand here. Just know that we are given a square matrix whose dimension is n cross n. Okay. Now let us discuss about what is this falling path they are talking about. See, idea is very simple here. See, you will have to start in the first row that is there. Next thing is how you will pick the next element. See, ultimate idea here is you will be starting in the first row and you will going to the one, you will go and pick one element in the second row, and like that you will pick one element from each of the rows until you reach the last row. Okay, but how to pick that element? See, there is some criteria here. For example, see this, the next element from position. See, suppose you are in this particular position. Okay, then the next element could be only one of these three. Okay, what is that? Let me tell you with the example. See, it's very clear. It's very simple actually. Suppose I'm at this particular one. Okay, as you can see in my screen, this is the one I'm talking about. Suppose I'm in this particular one. Okay, so what can be my next element? It can be either directly below it, that is 5, or it can be one which is diagonally left to it, okay, which is 6, or it can be the one which is diagonally right to it, which can be 4. So if you talk about one, what could be the next possible elements? It is 6, 5, and 4. Okay, only these. Remember, there are only three options. Okay, in this case, it was a 3 cross 3 matrix. But even if the size is bigger, that doesn't mean anything will change. Will it will still remain the same. Okay. Now, if you talk about, let us say, the element 3, what are the possibilities for it? See, first option is it can be 4, the next element after 3. The second option is it can be 5, because 5 is diagonally left to 3. There are only two options here because there is nothing diagonally right to 3, because 3 is, one of the edge elements. Okay, it is at the border. Okay, so there is nothing right of 3 diagonally. So this is the question. You can again go through it. If you have not understood my explanation, please go through it what they are trying to say. The idea is very simple. See, if you are at row 1, the next element should belong to row 2. That is one thing is clear, right? So if you are this particular row, the next element will always be from the next row. So as you can see, all the possibilities have this particular thing in common. Okay, now coming to which column you are going to choose. Suppose you are in this particular column. Either the column can be one previous to that, either it can be the same column, or it can be the one, right to that. So basically the idea here is either the element can be directly below the previous element, or it can be diagonally left or diagonally right. So for 1 the options are 6, 5, and 4. For 3 the options are 5 and 4, and for 2 the options are 6 and 5. So this is the way you have to do it. So idea here is will start with one element in the first row, and then you will go on picking the elements. But what is the ask of the question here? See, the ask of the question is return the minimum sum of any falling path. See, basically this is called the falling path. Okay, if you choose the elements like this and go from the first row till the last row, so it is called as a falling path. You're basically, you're traveling a path, right? They're asking the minimum sum of any falling path through the matrix. See some examples here. For example, you started from 1, you went through 5 and then 7. Okay, then there is another possibility, from 1, 4, and 8. So there are many possibilities here. These are some of them, but ultimately you have to tell the minimum sum in any of these possible paths. Okay, this is the question. I hope I have explained you the full, whatever is the dimension of the question, I've already explained you that. Okay, so this is the one. So this is the answer in this particular case, 1, 5, and 7. The answer coming is 13, and the sum you can take. So this is the second way in which you will get the same sum. Okay, and now coming to this, as you can see, these are negative numbers involved. So by the way, what is the constraint of this question? See, the matrix element can be from -100 to +100. Okay, and the n can be from 1 to 100. That see, this is not something very big. Okay, that's why I am saying this question cannot be called as a hard or medium question, because the dimensions itself make it easier. Okay, and now coming to the the yeah, how much the dimension of the matrix can be. As you can see, the dimension same. Okay, horizontal vertical direction same. They mean to say it's a square matrix. Okay, so yeah, that's it. Now how to do this question? See, one thing is very clear, right? uh, See, for example, try to understand this fact. See, it's telling you to start from the first row, but the idea here is, the catch here is, what see, try to understand this fact. Suppose I'm at an element, let us say 7. What Okay, if I am at 7, what could be the one next possible element for me? Obviously no possible element, right? So the idea here is, see, The last most element, see, if we start from the last most element, what you will do, see, suppose as you can see here, suppose there is only one row called 7, 8 and 9, and you will have to return the answer. What will be the answer, by the way? It will be the minimum most element, right? It will be 7, okay, in this case. Now come to case, right, this, okay. See, suppose I'm at a 6, okay, I'm at a 6. What path should I take now? Okay, either it could be 6 plus 7 or it could be 6 plus 8. So obviously I will take 6 plus 7. So the idea here is whenever I'm at 6, I should always take the 7. Okay, that's the idea, because that will give me the least possible. See, I can make 6 in two ways. Either I can reach 6 through 2, or I can reach 6 through 1. Whichever way I do, I should always take 7 as the next element. Okay, that is the basic idea. So see, that's what I'm going, trying to do here. See, what I'm doing, I will create a cache. Okay, I'll create a cache matrix of the exactly same dimensions. As you can see here, cache matrix is of exactly same horizontal and vertical dimensions. Okay, initially I'm keeping the I'm filling them with 101. Why like that? See, try to understand the fact. 101 will not fall in this range. Okay, so there will never be a case where element matches this. You can keep anything like that, by the way. It's not like only 101. Either you can keep it as a none also, because ultimately I will be assigning a value to it. Okay, for now you can keep anything. Okay, as simple as that. So that is one way. The next thing is try to understand this fact here. See, what is this cache of I comma j? See, try to understand this fact. What is cache of I comma j? See, cache of I comma j is, suppose I start at the I comma jth element. Okay, suppose I start at the I comma jth element. What will be the minimum sum of any falling path from that particular element downwards? So that means if I start at 6, what will be the minimum sum now for any falling path starting from 6? As simple as that. Why I need that? Because see, 6 will next be used by 2 and 1, right? So whenever you are using 6 by either through 2 or either through 1, always you will take 7 next, okay, after 6. That is the basic idea. So what I'm doing is, see, in this cache, as I mentioned, it's the same dimension as that of the original matrix. So but try to understand this fact. If I am in the last row, will there be any change here? See, if I am at 7, that does not mean I will take another path, right? Because 7 is the last element. So that's why only for the case of the last element, I am taking them the same as that of the matrix elements. So as you can see here, 7, 8, and 9, and in my matrix also, they are going to be the same. Okay, let me quickly print and show you first. I hope you would understand what is cache of I comma j. And as you can see, yeah, all the elements are 101, but only the last, only the last element is same as that of the given matrix. As simple as that. That's what I wanted to show you initially. Now come to the case of what I'm doing next. So one point is clear: the last row is already filled. Okay, we will be filling from the second last row till the zeroth row. Okay, that is from 6, 5, 4, then to 1 and 3. From the second last row till the zeroth row. Okay, I will be going through each element. Okay, that will be done through J. Okay, what I'm doing next? See, if I'm at 6, as I mentioned, there are only two possibilities. Either I can have 7 or I can have 8 next. Okay, so I will consider all such possibilities. Whichever is the minimum, that I will take, and then I will add it to 6. That's what I'm doing here. Initially, cache of I comma j is I'm see I comma j. First of all, I'm assigning the bottom of the element below it. Okay, cache I plus 1 of j. Okay, that is this particular element's cache. Okay, that I'm assigning to cache of I comma j. Okay, because I'm sure this element definitely exists. See, because I may not know if the left diagonal or right diagonal exists or not, but definitely the element below it will exist, because I'm starting from the second last row onwards. So definitely there is a last row. So there's the first case. Okay, now if the j minus 1, okay, what is this j minus 1? That is the left diagonal element. If this thing is greater than or equal to 0, that means that element exists. What I will do next? I will do that cache of I comma j is equal to minimum of the previous cache value. What is the previous cache value? This is the previous cache value, and the current, okay, this particular element. Okay, I plus 1 of j minus 1. Okay, I plus 1 of j minus 1. Okay, once I know, remember, matrix element is different. I am here dealing with only cache. Remember, the last row's cache is already updated. That's why I'm starting with the second last row onwards. Okay, so directly these cache values I will be using here. Okay, as such. Okay, the second case. Now come to the third case, where we are checking if the right diagonal element exists or not. In case if it is less than n, then definitely it exists. What I will do now, I will again check which is the minimum, the previous cache value or the cache value which is right diagonal to it. Okay, remember, matrix of I comma j is different and cache of I comma j is different. They are two different matrices. When I talk about cache of I comma j, what I mean? See, cache of I comma j means if I am starting at I comma j, what is the minimum sum of the falling path starting from I comma j? Okay, as simple as that. So see, in this question they're asking to start from first row, but in this calculation I can start from any row. Even if 6 I am talking about, a falling path can start from 6. I will try to find what is the max possible path, okay, from 6. Because that if I know that path, it will help me when I am dealing with the 2 and 1, okay, because they can travel through 6, as simple as that. That's what I'm doing. So after this done, I will quickly print and show you how it looks. I guess after that you will have a better idea. So let me quickly print and show you. So yeah, we are done with the results. As you can see, first of all, 789 is as it is, okay. This is the cache matrix, by the way. 789 in the matrix and in the cache are same. Now coming to second element, see second row. It is 6, 5, and 4, and it is 13, 12, and 12. What it means is, try to understand this. What is, I am at 6, okay. So what will be the shortest possible path now? It's 6 plus 7, okay. So what is 6 plus 7? 6 plus 7 is 13. Suppose I am at 5. What is the shortest possible path now? It is 5 plus 7, okay. So what is 5 plus 7? It is 12. Similarly, I am at 4. What is the shortest possible path now? It is 8 plus 2, which is again 12. Now coming to next element, suppose I am at 2, okay. What should be the next move? See, you will have to see this and decide, okay, which is the smaller. So if I am at 2, what are the two possibilities I can have? Either I can take this or I can take this. Which is smaller? 2 is smaller. Sorry, 12 is smaller. So I will do 12 plus 2, which is 14, okay, which is 14. Suppose I'm at 1. What are the possibilities? I can take any one of them, okay, which is smaller? 12 is smaller. So 1 plus 12 is 13, okay, as simple as that. Now coming to last element, 3. Suppose I am at 3. What are the possibilities I can take? These two. So 3 plus 12, what is the answer? 15. So among them, one is the whichever is the smallest is the answer, which is 13 in this case. Okay. So we are taking the cache. Initially, we are comparing it to all the values and we are taking the minimum. Once we are taking the minimum, I am adding the matrix of I comma j to the cache of I comma j. Okay. So yeah, that is the basic idea. I am simply printing the fact here, and once this is done, I am returning the minimum of the first of the cache. Okay. So let me quickly run this and show you. I've already segmented the solution and it works. Okay, it really works and it is really fast. Okay, as you can see, we are getting all the test cases cleared. So yeah, fine. That was all for today. So if you ask me what topics I am, what is the thinking process behind it? See, first thing is it's memoization, caching. See, caching basically means I am calculating some results which I will be using to calculate the next results. Okay, so there is no recalculations happening behind the scene. As simple as that. Nothing is going wasted. I am getting all the results. So now suppose if you are a pro coder and if you are watching my video, I'm sure that you will be thinking, something else can be done. So let me give you some hints here. See, if you are a pro coder or if you want to do something more, if just to satisfy yourself, what can be done next? See, try to understand this fact. See, whenever if you see my code, what I've written, try to understand this fact. I am always taking a one row below, okay, only one row below. So the idea here is, see, suppose I am at 6, definitely I know this particular row's cache. Okay, the last row's cache. I hope my mouse pointer is visible to you. Suppose I am in the first row, I need a second row's cache. Similarly, when I'm in the second row, I need the third row's cache. But when I'm in the first row, do I need the third row's cache? No, we do not need it. Okay. So instead of making a full matrix same as the dimension of the given matrix, what you can do is you can just take a um, just have a space of two rows which will satisfy, see, take the length of one row and similarly make two such rows. That should be enough. That's what it is. Because at any given scenario, what is all we need? We need only the cache of the row below it. Okay, as simple as that. So we don't need the whole matrix here. Okay. Now, if you talk about the dimensions here it's slightly smaller. That's why it doesn't matter much. But if it is, suppose, let us say 10 power 3 or something like that, then definitely we'll need to optimize it. Okay, you do not need to store the cache for all the rows. Okay, you just need to store the cache for the very next row for which you are calculating. As simple as that. Rest all the rows you can ignore and you can discard them. So that is the optimization which you can think of and you can implement. I have not done that because see, if I would have done that, it would look very complicated code for you and you may not be in a position to grab it. I am not done that, but I am expecting you to try that and get it by yourself, so that you also feel that involvement, you also feel that satisfaction. So I hope you understood what this question was all about and what is the logic which we are using. The topic which we are using is dynamic programming with memoization. As simple as that. So yeah, fine. That was all for today. If you want to have see, if you want any clarification, or if you feel there is better way of doing these things, please do let me know. We can discuss further. See, this is all about how much you can think of, how much time you're trying to spend here. Okay, it's all about that. I am just the medium, but it's all you. How much you want. Okay, if you want to make your life through this coding, then definitely you are expected to give more time or more efforts towards it. So be more communicative. please do comments below if you have questions, or if you want me to do something extra, like if you want me to do, uh, trace more and show something like that, you can let me know so that I can prepare better and come with satisfying expectations. As simple as that. So yeah, friend, that was all for today. We'll surely meet tomorrow. Thanks a lot.